Hello everyone, welcome to Sangam tutorials, SP Gubbi online classes for Ncert 10th standard and Cbse 10th standard for mathematics and science classes. So in the last class of polynomials, we had discussed regarding the zeros of the polynomials. So you went through various types of graphs, that is a graph related to quadratic polynomial and graphs related to cubic polynomials. So a quadratic polynomial at most has two zeros, it can also have one zero, and it cannot have any zeros also. So in a cubic polynomial at most it has three zeros, it can also have two zeros, also have one zero, that's the possibility, and it can also have no zeros. So this is the condition. So in the next class of that, in the next session, we came across the relationship between the zeros of a polynomial and its coefficients. So on that particular category, we have solved some problems. Some 7 to 8 problems were done on the board, and 3 problems were given to you as a homework, and many of you have sent the problem solved. And one of the polynomial, quadratic polynomial, which was given as a homework, it didn't have the zeros, so it's understood that both the zeros of that quadratic polynomial are some complex numbers or imaginary numbers. So it happens, so nothing to observe. This polynomial is, we are not getting zeros for this. So if you are not getting zeros for a quadratic polynomial, it is understood that it doesn't have zeros, means it has zeros, but both the zeros are complex or imaginary. It is to be understood in that manner. So in today's session, we will be going with a very important problems on particular topic, that is the required polynomial. So here in this category of problems, what we are going to solve today, we will be given sum of the zeros of a quadratic polynomial and product of the zeros of a quadratic polynomial. So using these two, we have to derive the required polynomial by using the standard form of the quadratic polynomial. So standard form of a quadratic polynomial, when the sum of the zeros and product of the zeros are given. So I have done it in the last class, that is we have derived it. So the required polynomial will be in the form of f of x is equal to x square minus m plus n, that is alpha plus beta into x plus alpha beta. So that's the general form or standard form of a required polynomial. So using this, we will required standard form of quadratic polynomial, we will solve problems on this. So we will be given two numbers. Among the two numbers, the first number stands for the sum of the zeros, and the second number stands for the product of the zeros. So two numbers will be given to us. So using the sum of the zeros and product of the zeros, we have to derive the required polynomial. Okay, this is the question. Find the quadratic polynomial with given numbers as sum and product of its zeros respectively. For example, first problem 2, 3. So this is the first problem. So in this problem, here 2 represents the sum of the zeros. See, you have to imagine like this. We have a quadratic polynomial, that is ax square plus bx plus c. That is the quadratic polynomial. It has two zeros. One is alpha, another is beta. So he has added both alpha plus beta, he has added. So when he has added that alpha plus beta, he has got 2 as the sum, and he has multiplied alpha and beta, that is alpha into beta is alpha beta, and that value is 3. So he has given that, and he is asking you to find out the polynomial itself, from where these zeros you have got. So that means from where the zeros have come out, that particular polynomial we have to find out that, we have to derive that. Okay. So here 2 is the sum of the zeros. So sum of, okay, let us start with this. Let alpha and beta be the two zeros. Let alpha and beta be the two zeros. So sum of zeros, we write down sum of zeros, okay, is equal to, it is represented by alpha plus beta, which is equal to 2, and the product of zeros, okay, product of zeros is equal to alpha into beta is equal to, it is 3. So this is the given data for us. So using these two, we have to find out the required polynomial. So required polynomial is given by required polynomial is given by p of x is equal to x square minus alpha plus beta into x plus alpha beta. So this is the standard form of the required polynomial. So now, p of x is equal to x square minus alpha plus beta, value is 2, substitute that 2 here into x plus alpha beta value is 3. So therefore p of x is equal to x square minus 2 into x is 2x plus 3. So this is the required polynomial. So by using the zeros, that is sum of the zeros and product of the zeros of two polynomials, that is a polynomial, we are going to find out the polynomial itself. Right. So we'll go with the next problem. Second one, 1 by 4 comma minus 1. So here first number should be taken as the sum of the zeros and the second number should be taken as the product of the zeros. Okay, let us go with the solution. So as usual, let alpha and beta be the two zeros. Let alpha and beta be the two zeros. So sum of zeros is equal to alpha plus beta is equal to, value is 1 by 4. We write on that. Next is product of zeros. Product of zeros is equal to alpha into beta, that is equal to minus 1. So be very careful with the sign. So required polynomial, we will write the standard form. Required polynomial is right. So you can take it as p of x is equal to x square minus alpha plus beta into x plus alpha beta. So p of x is equal to x square, as usual we will write this, minus what is alpha plus beta? It is 1 by 4 into x plus what is alpha beta? It is minus 1. Keep it inside brackets. Be very careful here. So p of x is equal to x square minus 1 by 4x plus into minus is minus 1. So here we are having 4 in the denominator. So what is to be done? So you can leave the answer in this format itself, but many steps what we do is we take this to the standard form of the polynomial. We are not going to leave this 1 by 4 here. So very simple, what is to be done here? It's very simple, nothing to worry. See what is in the denominator. We have 4 in the denominator. So multiply each and every term in the polynomial by this denominator. So what is to be done? Look at the number in the denominator of the fraction. So what number is there in the denominator? Just multiply that by that number to the entire polynomial. So this becomes, so therefore p of x is equal to 4 into x square is 4x square, minus 1 by 4x into 4. So 4 and 4 cancels, so it is minus 1x or minus x. So 4 into minus 1 is minus 4. So very simple, nothing to worry. Just multiply the entire polynomial by 4. Or you can take 1 by 4 as common out of here, and you can substitute some values to balance that. So all that leads to errors. Nothing to worry. Let's just do this. Look at the number in the denominator. Multiply this by this number, the entire polynomial. You will reach the standard form of this required polynomial. So this is how you have to solve problems when the sum of the zeros are given and product of the zeros are given. Right. We'll go with the third problem. Root 2 and 1 by 3. So here root 2 is the sum of the zeros of the required polynomial and 1 by 3 is the product of the zeros of the required polynomial. So we will go with this. So let we guess the zeros, let alpha and beta be the two zeros. Let alpha and beta be the two zeros. Okay. So let us write down the sum of zeros. Sum of zeros is equal to alpha plus beta is equal to that is root 2. Alpha plus beta is equal to root 2. Okay. Very simple. Product of zeros. Product of zeros is equal to is alpha into beta, that is given as 1 by 3. Okay, nice. We have collected the data. Now we will write the required polynomial. So required polynomial is given by very simple. You can take f of x, you can take p of x, g of x, whatever you want, it's your wish. F of x is equal to x square minus alpha plus beta into x plus alpha beta. So f of x is equal to x square minus, what is alpha plus beta? Alpha plus beta is root 2. So root 2 into x plus alpha beta is 1 by 3. So we will correct this. F of x is equal to x square minus root 2x plus 1 by 3. So 3 remains in the denominator. What is to be done? So very simple idea. What I told you in the last problem. Multiply by this number, that is 3. That multiply by 3 to the entire polynomial. So it becomes f of x is equal to 3 into x square is 3x square. 3 into minus root 2x is minus 3 root 2x plus 1 by 3 into 3 is 1. So this is the required polynomial. So it's very simple. Because here, sir, why we have to multiply this entire polynomial by 3 means because 3 acts as a constant. In the derivation I had showed you p of x is equal to k into x square minus alpha plus beta into x plus alpha beta is equal to, that is, it was equated where k was called as a constant. So the same constant is 3 here in this example. So we have to multiply this 3 by 3 to this entire polynomial to bring it to the standard form. So I will keep the answer in this format itself. No problem at all. You can keep it. If you want to bring it to the standard form, multiply by the entire polynomial by 3. That's all. That's the only change I am going to give. Right. We'll go with the next one. Fourth problem, 0, root 5. So 0 is the sum of the zeros and root 5 is the product of the zeros. So let us guess it. So let alpha and beta be the two zeros. Let alpha and beta be the two zeros. So sum of zeros is equal to alpha plus beta is equal to 0. Very simple. Product of zeros is equal to alpha into beta, that is root 5. Okay, no problem here. We have collected the data. I hope you are feeling easy. So we will frame the equation. So required polynomial is given by p of x is equal to x square minus alpha plus beta into x plus alpha beta. So p of x is equal to x square minus, what is alpha plus beta? It is 0. Okay, no problem. Write 0 into x plus alpha beta is root 5. Okay, bring it to the standard form. X square minus 0 into x is entire term gets cancelled. So minus 0 into x is 0 plus it is root 5. X square plus root 5 is the required polynomial. I hope you are feeling it easy. 4 problems are over. Still more to come. Until now, these problems can be asked for 1 or 2 marks. minus 1 by 4 comma 1 by 4. So these are the two zeros. So we have a polynomial. For that polynomial we have two zeros. When we add those two zeros we get minus 1 by 4. When you multiply those two zeros you get 1 by 4. So this is given. We have to go to the required polynomial. So first step is guessing the zeros. So let alpha and beta be the two zeros. Let alpha and beta be the two zeros. So we will find out we will write the sum of zeros. We will write the data here. Sum of zeros is one zero is alpha, another zero is beta. So alpha plus beta, they have given it as minus 1 by 4. So next is product of zeros. Very simple. Is equal to alpha beta is equal to, that is 1 by 4. So sum of the zeros, product of the zeros is ready. So therefore you can directly go to the required polynomial. So required polynomial is given by very simple, x square, that is p of x is equal to x square minus alpha plus beta into x plus alpha beta. So p of x is equal to x square, I will write it, minus alpha plus beta. Alpha plus beta is minus 1 by 4 into x plus alpha beta is 1 by 4. No problem. So p of x is equal to x square minus into minus becomes plus 1 by 4x plus 1 by 4. So we can stop the answer here, but if you wanted to bring it to the standard form, look at the number in the denominator. So it has 4 at both the places. No problem. Multiply the entire polynomial by 4. So therefore p of x is equal to x square, that is 4x square. When you multiply by 4, 4 into x square is 4x square. 1 by 4x into 4 cancels. So remaining thing is x. And last term 1 by 4 into 4 cancels, that is 1. So this is the required polynomial. So I hope you understood the problems here. So I will give you homework problems. Just do this. 1 comma minus 4, and second problem is 4 comma 1, and third problem is root 3 comma 0. So these are the 3 problems. You have to do it in the same manner, no changes. I hope you are enjoying all the problems. I hope it is very easy for you. These are the homework problems. This is the sum of the roots, product, sum of the roots, product, sum of the roots and product. So now we will go with a very interesting problem from an Ncert exemplar. It's given from the Ncert exemplar. Find the quadratic polynomial. You have to find the quadratic polynomial. Sum of the roots will be given, product of the roots will be given, and you have to find the required polynomial, no doubt in that. After that, you have to find out the zeros also. You have to find out the zeros also. That's very important problem from Ncert exemplar. So here, let us go with the solution. Okay, write find the quadratic polynomial if sum of zeros is, the sum of the zeros is given, that is as root 2. Sum of zeros is root 2. Product of zeros is minus 3 by 2. So he has given the sum of the zeros and product of the zeros. You have to find the required polynomial. So same method what we have done until now, we will do it. So along with that, what we have to do is we have to find the actual zeros of that polynomial. Actual zeros. So find the zeros also. So it is from example. It is from Ncert exemplar problem, which was asked in one of the examinations in Cbse. So it's an important problem. Let us solve it. Okay. Find the quadratic polynomial if sum of the zeros is root 2, product of the zeros is minus 3 by 2. Find the zeros also. So first we will find out the required polynomial and then we will find out the zeros. I will tell you how to find out the zeros. Okay. So usually we will guess this. Let the zeros be alpha and beta. Let the zeros be, two zeros be alpha and beta. So sum of zeros he has given. Sum of zeros is equal to alpha plus beta is equal to alpha plus beta is sum of the zeros is given, that is root 2. So I will write root 2 here. Okay. Next is the product of the zeros. Okay, very simple. Product of zeros is equal to alpha into beta, that is sum of product of zeros is minus 3 by 2. Very simple. So we have got the data here. So now we will write the required polynomial. So required polynomial is given by p of x is equal to x square minus alpha plus beta into x plus alpha beta. So p of x is equal to x square minus alpha plus beta is root 2. So we write root 2 into x plus alpha beta is minus 3 by 2. Okay, keep it inside brackets. So p of x is equal to x square minus root 2x plus into minus 3 by 2. So it's not in the standard form. Let us take it to the standard form. So the number in the denominator is 2. Let us multiply each and every term in the polynomial by 2. That's very simple. So p of x is equal to 2 into x square is 2x square. 2 into minus 2 root 2 is minus 2 root 2x, and then minus 3 by 2 into 2 is minus 3. So this is the thing. So here we have got the required polynomial. So we have done half of the problem now. We have found the required quadratic polynomial. So now the task is to find out the zeros also. So here p of x is equal to 0. You have to equate p of x is equal to 0 because for this polynomial p of x you are going to find the zeros. So if you want to find the zeros of p of x, then x should be equal to 0. That is, p of x should be equal to 0. So equate this p of x equal to 0. So therefore 2x square minus 2 root 2x minus 3 is equal to 0. We will equate this. 2x square into minus 3, it's a quadratic equation now. You can solve any quadratic equation by sum and product method, what we have learned in our previous sessions. So 2x square into minus 3 is minus 6x square. We have to split this such that, in such a way that if you add these two terms, you should get minus 2 root 2x, and if you multiply these two, you should get minus 6x square. So we can take it as 3 root 2 x and root 2x. So this can be given minus and this can be given plus. So here minus 3 root 2 plus root 2 is minus 2 root 2. Minus into plus is minus 3 root 2 into root 2. So this becomes like this, 3 root 2 into root 2. So that becomes 3 into root 2 into root 2 is root 2 whole square. Square and roots cancels. 3 2s it becomes 6 and x into x is x square. I hope it gets 100% tally. So 2x square, instead of minus 2 root 2x, we will write this and this. So minus 3 root 2x plus root 2x minus 3 is equal to 0. So we will take here this and this. We can take here root 2 as common. If we take root 2 as common and x as common, root 2x as common. So we have root 2x, because root 2 into root 2 gives root 2 whole square, where square and root gets cancelled. So that becomes 2. X into x is x square. So root 2x is taken out. So therefore we are left with 3 here. So here plus root 2x minus 3 is there. Nothing can be taken as common here. So therefore we will take 1 as common. So root 2x minus 3 is equal to 0. So out of these two terms, we can take root 2x minus 3 as common. So root 2x minus 3 as common. If you take, in this term you are left over with root 2x, and in this term you are left over with plus 1, which is equal to 0. So this into this is 0, means either this should be equal to 0 or this should be equal to 0. So we get that to zeros. So root 2x minus 3 is equal to 0. And as there is another root, root 2x plus 1 is equal to 0. So root 2x is equal to 3, that is minus 3 gets so transposed, that becomes plus 3. So x is equal to 3 by root 2. So this is one of the 0. And here root 2x is equal to plus 1 gets transposed, that it becomes minus 1. So therefore x is equal to minus 1 by root 2. So this is another 0. So we have got exactly 2 zeros here, because as this is a quadratic polynomial, we have got 2 zeros. So therefore the 2 zeros are 3 by root 2 and minus 1 by root 2. So these are the 2 zeros, and this completes your answer. So it is an attachment of a single problem here. So that is finding out, until here we find out the required polynomial, and after this we find out the zeros of that polynomial by equating the polynomial equal to 0. Because we are finding out the zeros of the polynomial, we should equate p of x to 0. So this is the method for that. So this may be asked for 2 marks in your examination, right? So here I hope you have enjoyed the entire session today. So very nice problems were done. First problems on 2 marks, another problem on 100% it is asked for 2 marks. So it's very important problem. Please practice the problems. In a very few days I am going to give you a test on this. So you should be well prepared for this. So please subscribe the channel, put a like button on it. Stay home, stay safe, and keep learning. Thank you.